Hey guys, sorry I couldn't be there today. So today what we're going to be doing is reviewing a lot of things that you guys did in algebra last year. So we're going to review square roots and their properties, review how to simplify square roots, and review the operations of roots. So throughout today's notes, when you guys, especially when you guys go through this, I want you guys to recall it's very similar to what you guys did in the flip classes. Take notes on the paper that's given to you by the substitute teacher. Pause the video whenever I ask you, and then show work. Continue your notes after doing the work. All right? Hopefully you guys got this. So the first thing, a lot of you guys are wondering about the final. Since I'm not there today, most likely you guys will get back to final on the block day. Okay? The reason being is there's still a couple people who still need to make up the final. So today's lesson is 8.1, simplifying square roots. So let's go over certain things you guys should recall from algebra last year. So we all know that what the answer to this is, but let's go over some of the vocabulary that you guys should know about the parts of a root. So the symbol, hopefully you guys know, is called the radical or root symbol. Now the number inside the radical or root symbol is called the radicand. This is hardly used, but you should recognize what that word is if you see it in some text. So your experience from last year, you should also know that when you have root 4 or the square root of 4, there's an imaginary 2 there. You don't have to write the 2, but if you would like to, go ahead. However, when you have a cube root, the 3 has to be in that little valley. So if I ask you what the cube root of 8 was, you guys should know it does equal to 2. Again, you should know this already from last year. So let's see if you guys have memorized all of these square roots. Let's see if you guys can do this in 20 seconds. Pause. Do it now. So you guys should know you're at these. And at this point, guys, since this whole chapter is all about the Pythagorean theorem and its applications, you have to memorize all these. And I expect you guys to know this instantaneously. Okay. All right. So those are the perfect square roots that you guys should memorize or should have memorized from last year. I think you guys do. It just takes some recalling. Let's see if you guys remember how to simplify certain roots. So the way I've always taught algebra and approached this is I know it's not a perfect root, and I had to figure out what's the biggest perfect root that goes into root 20. So I should know this equals to root 4 times 5. And I can take a square root of 4. So if I simplify it, the answer will become 2 root 5. Now, a lot of you guys are asking me, do I have to show that work in the middle? My answer to is no. I don't want you guys to show me that work. You guys should be able to do these types of problems all in your head, since you guys did this over and over last year. So for example, root 18, the answer should be 3 root 2. For root 32, the answer should be 4 root 2. For root 72, that's going to become 6 root 2. Again, I'm going to speed through this because I expect you guys should learn this last year. So, if I was going to do square root of 500, this is going to take some thinking. And for this one, I will show you guys some of the work. This is basically root 100 times 5, which equals to 10 root 5. Again, I know a lot of you guys were able to do that in your head. Root 162, very troublesome, but you guys should know that 162 is just 81 times 2. Thus, the answer is going to eventually become 9 root 2. So, one of the things you guys should recall is this basic property right here. Whenever you have a square root with multiplication inside, you can separate the two roots. Now, this is just an example, root 36. Root 36 basically equals to root 4 times root 9, which eventually equals just to 2 times 3, which equals 6. Again, you don't need to do that if you already know what square root of 36 is. Let's say I did not know what the square root of 900 was for this one. I could definitely separate it. So if I have negative root 900, I can separate that to negative root 9 times root 100, which eventually equals to negative 3 times 10, which eventually equals to negative 30. Okay. Again, I'm speeding a lot through these topics because I expect you guys to know them from last year. You probably covered all these topics in about one chapter. So we're covering one chapter in one class period. So let's say I have this problem. Root 36 over 121. When you have a fraction in a root, what you try to want to do is try to simplify it if possible. So you guys can simplify this if you want. But I know another way, according to the rule that's notified on the left-hand side in the red, I could simply just square root the top, square root the bottom. And therefore my answer would just become 6 over 11. Okay. Hopefully you guys got that part. Let's say I want to go further in simplifying roots. Let's say I have 3 root 28. Again, that means 3 times root 28. So a lot of the times I expect you guys to be able to do this in your head. But if you guys can't, yeah, you guys can show work. So 3 root 28, and if I wanted to simplify root 28, that becomes 3 times 4 times 3 root 4 times 7. I can take square root of 4, so that simply becomes 3 times root 4 times root 7, which is 3 times 2 times root 7, which eventually equals to 6 root 7. Now, do you have to show all the work in the middle? No, you don't. If you guys can get from 3 root 28 to 6 root 7, good. I kind of expect you guys to do that. Okay, let's say I have 7 root 125, and I'm not able to do that in my head. Well, 7 root 125 becomes this, 25 times 5. I can separate that to this. I can take the square root of 25, which is 5. Multiply 7 times 5, which is 35 root 5. Okay? Let's go to the next slide, which talks about adding roots. One of the things you guys should know about roots is that roots act like like terms. At this point right now, you cannot add these roots. You do not see any like roots. None of the roots are the same. But what you guys could definitely do with these roots that you see before you is you can simplify them. 25 root 2 is already in simplest form. I could definitely simplify 2 root 27. That becomes eventually 6 root 3. And then 3 root 98. Well, I should know that 98 is equal to 49 times 2. So that eventually becomes 21 root 2. So now at this point, guys should recognize that there are two like roots. 25 root 2 plus 6 root 3 minus 21 root 2. The root 2's are like, so my eventual answer will become 4 root 2 plus 6 root 3. And that's your answer. Okay. Let's see if you guys remember how to multiply roots now. To multiply roots, it's fairly easy. You just multiply radical times radical, or root times root. So root 3 times root 5 is equal to root 15. Root 7 times root 7 equals to root 49, which can be simplified to 7. Now, you guys should remember a certain property about squaring roots. Roots and squares, or square roots and squares, are opposite of each other. They actually cancel each other out. So root 5 squared is just simply 5. Let's go to more roots. We have 3 different problems here. Whenever we have roots, remember our goal is to get it in simplest form. For the first one, 5 root 2 times 4 root 3, I'm going to multiply 5 and the 4. They kind of act like coefficients. So I'm going to multiply 5 and 4, which will then become 20. I'm now going to multiply the two roots. So root 2 times root 3 equals root 6. And now I'm going to see, can I simplify that still? No, I can't. Okay. The next one, 4 root 3. You could definitely distribute the root, like I've done here. So that becomes 4 squared, which equals to 16. Root 3 squared will eventually equal to 3. So my answer becomes 48. Again, you don't have to show me that middle work. If you guys could do it in your head, good. For the next one, I'm going to do something very similar to what I did on the top problem. I'm going to multiply 3 times 2, so that's 6. I'm now going to multiply root 6 times root 3, which is root 18. However, at this point, I can still simplify. So if I simplify root 18, I can pull out a 3. So this eventually becomes 18 root 2. Okay, we have a few more problems, guys. For number 1, go ahead and try to simplify this. Please press pause. So this equals to 40 root 63. Root 63 can still be simplified. So this becomes eventually 120 root 7. For number 2, please press pause now. So for number 2, this becomes 12 times root 36. It still can be simplified to 12 times 6, which equals to 72. Okay, for number 3, you guys can try to do this, but if you guys are confused about it, you guys can follow along with me. So I'm multiplying these two fractions. There are multiple ways to go about doing this, but what I'm going to do is just straight up multiply them. And this is what it looks like. Root 10 thirds times root 27 32nds equals to 1 big root 10 over 3 times 27 over 32. How's that going to help me? Well, I'm basically multiplying fractions, guys. So I could definitely cross cancel. So the 3 becomes a 1, 27 becomes a 9, the 10 becomes a 5, 32 becomes a 16. So this eventually becomes root 45 over 16. Now I can definitely now take a square root of the numerator and denominator. So the numerator simplifies to 3 root 5, and the denominator simplifies to 4. For number 4, I'm going to do the same thing. I'm going to put this all under one radical. 3/7 times 14 over 27. I'm now going to cross cancel. 3 becomes a 1, 27 becomes a 9, 7 becomes a 1, 14 becomes a 2. This eventually becomes root 2 over 9. I can then take the root of the numerator and denominator. So this eventually becomes just root 2 over 3. For number 5, this is something you guys should recall in doing from last year. You guys should have done this over and over and over. You guys should notice that there's something that we don't like about it. We don't like the fact that there's a radical in the denominator. So you guys should recall, in order to get rid of a root in the denominator, you just have to multiply that root 5 by itself to the denominator and numerator. So if I want to get rid of the root 5, I multiply this by root 5 in the denominator, and I multiply it to the numerator. Eventually, my answer becomes 3 root 5 over 5. And that's it. So for number 6, there are so many ways to go about doing this. Some of you guys might do it a different way than I have done. Go ahead and do it that way. So what I'll do is separate them. Root 7 over root 8. What I do know is I can simplify root 8. That then becomes root 7 over 2 root 2. So I don't like the root 2 in my denominator. So what I'm going to do is multiply root 2 to the top and bottom. Root 2 here, root 2 here. Now I'm going to multiply and simplify. So root 7 times root 2 is root 14. Root 2 times root 2 is 2, times the 2 in front, which eventually equals to 4. For the next one, number 7, I'm going to go about doing this very similar to what I just did in the previous problem. I'm actually going to simplify first. You don't have to do that, but that's how I like doing it. You can multiply both top and bottom by root 24, and you'll still get the same answer. So I'm going to simplify the denominator. So that becomes 9 root 3 over 2 root 6. I don't like the root 6, so I'm going to multiply top and bottom by root 6. So this eventually becomes 9 root 18 over 12. I'm now going to simplify my root on the top. That eventually becomes 27 root 2 over 12. So if you look at it, it's still a fraction. You can still simplify this. You can simplify the 27 and the 12. And so that's eventually becoming 9 root 3 over 4. Okay, guys. Number 8. If you guys want to try it on your own, you may want to pause now. If not, just follow along. So for what I like to do is simplify first the radicals. I'm going to simplify both top and bottom one. So 75 becomes 5 root 3. Denominator becomes 6 root 2. I don't like the radical in my denominator. So I get root 2 and root 2 to the top and bottom. If I eventually simplify, I get 5 root 6 over 12. All right. I'm hoping that you guys got this. I'll see you guys tomorrow. Go ahead and start the homework.